Welcome to today's webinar. The topic today is seismic design of reinforced concrete structures in RFEM 6. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the content of the website, the German and English webinars, newsletters, and so on. I will be the moderator today, and I will answer your questions together with Alexander. Juliana will do the presentation, but my two colleagues can introduce themselves.
Okay, hello, my name is Juliana Stopper. I'm working in the Dlubal team for customer support on the one hand, and on the other hand, I'm supporting the developers of the add-ons concrete design and geotechnical analysis. Yeah.
Hello, also from my side. My name is Alexander Mayhofer. I'm head of product engineering concrete. I work in the development of the concrete design add-ons and FEA analysis together with the geotechnical analysis. And I will answer today your questions.
Okay, thank you for your introduction. Then we can switch off our webcams so that the attendees can see the full screen. I say some words for the attendees who participate the first time, how you can ask questions. You can show that panel here with the arrow, and then you can enter a question here in that field, and we will answer you. In the case you don't get an answer during the webinar, because there are too many, you will get an email afterwards. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, that's all from my side. Then I hand over the screen to Juliana.
Thank you. I will share my screen. Do you see my screen? Do you see the right one?
The content,
okay.
Yes.
Great, okay. Yeah, so we start with the content. Currently we are in our introduction, and the next step will be the presentation of the model and loading, as I have prepared a model so that we can today focus on the design. I want to introduce this model to you in the first step. In the second point, we will have a look at the design objects, at the configurations, all the settings that are new for the seismic concrete design. And after this, we will have a look at the design, at some special checks, design checks in detail. Yeah, this will be the main part of the webinar. Afterwards, we want to quite shortly provide a prospect. We want to tell about features you can expect in the next time for the concrete design. Yeah, okay, then this is the content. We can go to a next slide. I have prepared the slide as orientation. If you think about the design process for concrete members for seismic design situation, and divide this process in the following phases or steps. The first and second step are the preparation, and then the analysis and design according to Euro 2 comes. And for this, we have webinars provided on our website. There you can follow the concrete design in detail. Then you also need to do the seismic analysis according to Euro 8. For this, we also have special webinars provided on our website. There you can follow the modal analysis, the response spectrum analysis in detail. So these steps, step 3 and 4, are already done in my model, as we today want to focus on the seismic design and want to have the time for it. So these points 5 and 6, the seismic design according to Euro 8 for concrete members, will be the content of today's webinar. Yeah, okay, this shall be enough as introduction. We now go to the program. I open my model. I want to open this one. Yeah, this is the building we will have a look at today. But before we do this, we open the base data. And in the base data, you can see we have our register add-ons. And in my model, I have the concrete design active, and I have for dynamic analysis, the modal analysis and the response spectrum analysis active. As you know, in our finite element program, in the main program, when you activate these add-ons, the needed input dialogues and program parts and output for these add-ons are integrated. So what we need to look at is the next register too, the standards, because you have to tell the program, of course, according to which standard the design shall be done, and also for the dynamic analysis it is needed to be given. So today we will have the Eurocode as standard we want to use, and I want to show we have here an overview about activated standards. And if you here select the concrete design, you can see the standards that are activated in the concrete design, and you can see here that we have the Eurocode 8 now integrated. Okay, this is enough, I think, for the base data. Nothing else that is new. Okay, then we can go back to the model and have a look at it a bit. So it's a reinforced concrete building that has 5 floors, and we have shear walls at every side, at least one, and we have columns that no, we also have this U-shaped concrete core here in the center of the building, and we have columns that go from the bottom of the building up to the top continuously, and they have the same cross section along all over the height. And we have here beams between all vertical members placed. Yeah. And you can see these blue surfaces I have in the building. They are just used to allow me, I forgot the name, that's why I go there, load transfer surfaces, for giving a simplified load for the staircase. Okay, I go back to the top and close this. Then we can, yeah, this is what I wanted to tell. Maybe I can show also the supports. I have nodal supports at the bottom and line supports. We can activate here, and yeah, there you can see that it's grounded on springs. Okay, then we can have a look at the loads. We can activate them here, and I have in my model the load case 1, which is for self weight. And if you want to check the self weight, if you want to check what the program calculates from the cross sections and the materials weight, you can have a look at this and check these values, for example. Okay, I deactivate this. Then I have in my building a dead load placed, and also a live load. Yeah. Then I want to show the dynamic loads. Therefore, I go into the dialog where they are defined. We have here load cases and combination, and I open this. Okay. Yeah, and here we can see our load cases. So we had a look at the first 3 of them. And my 4th load case is a load case of the analysis type modal analysis. So it's selected modal analysis. And there we can check the modal analysis settings. I will just show them. As I said, we have extra webinars where you can in detail see why which setting is needed or used, or something else. And we also provide trainings for this. So in my situation, I have 10 modes considered, and we consider the X and Y direction. And I have in this register user-defined that I neglect masses, and I neglect masses from some structure parts that are placed in the support plane, let's say at the ground. Okay, then the modal analysis needs a load case defined or a load combination. From that it can take or import the masses. So I have this combination 8. From that the masses will be taken in my load case 4. What I have activated else is the structure modification. We need, according to Eurocode 8, for concrete structure, we need to consider the correct material values. If we don't do this, it is allowed to consider it as if you use the uncorrect material and reduce the stiffness by 50%. And this is what I'm doing here. I activate a structure modification, and I can activate and create a new one with you. So I have here a structure modification and different options. What I want to modify is the stiffness for my members and surfaces. And with these checks, we have these registers open, and I can define a new member modification. And I select the modification type. I want to have factors for partial stiffnesses. And here I can select reduced stiffness of 50% for bending and for shear. And in my model, I have torsional stiffness of 10%. Okay, and then you can assign it, and you have a stiffness modification here. This is what I now created. Okay. Yeah, and you have to assign the members, of course. I only wanted to show this. I have this already prepared. I can remove this. We can have a look at this. Yeah, here it's, like I said, you can define the stiffnesses and reduce them. I also renamed it, so it's easy to follow why I have this here. It's according to the chapter 431 of Eurocode 8, clause 7. Okay, so this is how my modal analysis load case is defined. Then I have my response spectrum. I have this analysis type response spectrum analysis set for this load case. And this load case needs a modal analysis load case. So I have my load case 4 assigned here. And I have spectral analysis settings for this case that I also only want to show. I have the SRSS combination rule, and I have the settings activated that I want to save the results of all selected modes. And the directions will be combined by the 130% rule. Yeah, these are the settings that I used in this model. And the accidental torsion is activated. Okay, then let's have a look at the response spectrum. If you open this case the first time, it looks like this, and we have X and Y direction we want to consider, so you have to activate it, and then you can assign a spectrum. And I want to show you the spectrum I assigned. You have here the definition type, and it's also possible to have a user-defined spectrum or a generated from accelerogram. But we now today want to have the one according to standard. Then you have to give your design parameters you have for your building, and we have spectrum type 1 we want to use. We have ground type B, importance class 2, and this ground acceleration, and we have a behavior factor of 2. We will come back to this value later as it is relevant for our design. So we have in our response spectrum the behavior factor 2 assigned. And we can also see here these ground type parameters, and we have these periods, and this one, the TC, will also play a role later in the concrete design. Okay, then we can leave the spectrum. Yeah, that's it, what I wanted to show for these dynamic load cases. Then we can have a look at the further registers. These are the 3 action categories that are now modeled in this file, summarized. Then we can go to design situations. We have the design situation 1, 2, and 4 that are known from the concrete design according to Eurocode 2. And we have this design situation 5. This is the design situation that was created for receiving a load combination where the mass for the modal analysis can be taken from. So we have here design situation type. We can open this and we can see seismic mass combination type. Yeah, and if you want to see the rule of combination, you can click on this button. So this is the design situation type. This is the design situation that creates my load case for the modal analysis for the masses. For the concrete design, I need this design situation 6. We can have a look at the types again. There we have the seismic type, the ULS, STR, geo seismic. This is the combination type according to Eurocode 8 for the seismic design according to Eurocode 8 for concrete members. Yeah, for other designs it could be also used, of course, but now we have here concrete design. And we assign a combination wizard here. We have from the response spectrum used, therefore we need here a result combination type. So this design situation generates result combinations for us. When we look in the previous design situations, they create or generate load combinations. Okay, then we can see our actions combined, and here are the load combinations that are generated from the first design situations, and we have here in the result combination the seismic result combination. Okay, that's all what we need for the design from the loads. I will close this. I have already results in this model, so I don't save a setting or something. Okay, this is it from the model and from the loads. I would like to shortly show you some results here. We have results that we go on the results button. We can shortly see the model analysis. Yeah, here we can see the first mode shapes. We can see that the first shape is more in the Y direction and the second in this direction. No, this one is a Y direction, the first one was an X direction. So we have the model analysis results, and we also have the response spectrum results. In the response spectrum, here spectral analysis, you can check the inner forces that come from the response spectrum in the members. These forces then are taken for the result combination and later go into the concrete design. Okay, so this is a short view on results. I will again switch them off and we go back to our navigator. Now I want to come to the concrete design. My model already has reinforcement. I can also show this. Yeah, we have in the navigator display, we have the option to display the reinforcement, and I will do this now just shortly for you. here we see. So this is all the members in my building that I have reinforced now. And if we look here, I can click on the column, for example, and do a right click, and we can, you can also do a double click on the member. This works as well. And I want to show the reinforcement. In this column, I have uniformly surrounding longitudinal reinforcement. And I have here the shear reinforcement. And what we have and need for the seismic design is we have these cross ties. They are needed to have a more confined concrete core in order to receive a more ductile behavior of the members. So you can activate it in the shear reinforcement, and you can modify it via clicking on the longitudinal bars. So if you have more longitudinal bars and you don't want cross ties between all of them, you can just click on the longitudinal bar and the cross tie will disappear or come back. Yeah, this is the thing about the cross ties. Okay. Then, as we are already here, I want to show in a short, let's say, excursus, I want to show a feature we recently released. You can here, you have the option always in a member to see the reinforcement layout, and you can modify the way it is displayed here. You can, for example, you can do a setting where you only see the longitudinal bars and no stirrups, for example, or something. You can do as you like it or you need it. And when you did this setting once for reinforcement layout for printing, you can print this now to a template. And this can be then used for more than one members. You can give the name, for example. I say columns, and maybe I say 2 because I already did this, but for you. Okay, now I printed this setting. It can be something else. It's but now I did this one, and now I have this template saved the way of I like my reinforcement layout, and I will go this and go back here. And now if you say print graphics to printout report, it's possible to, I will deactivate this button. I don't want to now print the model or the loads or the add-ons. We are here. We have the multi-print activated, and I don't want these. I want to show you the graphic templates. So these are templates that I have prepared before, and I now want to use my column reinforcement template. And you can use it for all members. Now it's 195 detected, but I want to select it. And you can use this mouse for picking the members you want to print with this layout. And I have an object selection prepared. I have now my columns 8. These are my columns in this position for the whole building. I want to print with this reinforcement layout that I prepared before. And yeah, I go back here. Okay, I can say okay, save and show, and then it is printed now to the printout report, and after it is finished, it will show the result to us. Okay, I had a very short printout report prepared, so we can have a look at this. Yeah. And now here you can see the members that are all printed with the same layout, and you have these graphics here. Yeah. So with this template, you can easily print for a lot of members the reinforcement layout. Okay, enough for this. Let's go back to our seismic design. I want to show the building again with like this. Okay. Now I want to go to the further seismic settings. We have here the folder for concrete design, and if you do a right click on this, you can reach global settings for the concrete design. And in this first field, you can select which configurations you want to have in your model. And in my model, I have ultimate active, we have serviceability active, and I have the seismicity active. So if this is activated, I have seismic configurations in my model. Okay, and at these we will have a look now. Here you can see the seismic configurations, and I open them now. Okay, and we are here. I collapse them. So here we have all the configurations you can do for controlling the seismic design. And the first setting that we provide is the selection of the ductility class. We have the known low ductility, medium, and high ductility class. If you select the class, the provided input here changes. So if we go on low ductility class, you can see that the configurations were reduced because the low ductility class needs a design according to Eurocode 2 and has no further requirements for capacity design or ductility, but a very small behavior factor is allowed only. So, and it should be taken only for low seismic activity. Okay, so let's go back to medium ductility class as we can see more of our settings like this. Okay, the second option is the option to define the structural system type. And if you have the case that you have different types in the different directions X and Y, you can also activate this check, and you can define the system type for both separately. Now in my case, I have in both directions the same type. And this type influences the behavior factor, the basic behavior factor. Okay, then the next setting is for seismic elements. As default setting, we have the primary seismic elements, but if you have in your structure secondary seismic elements, which means you have elements that don't belong to the system that have to carry the seismic loads, then you can define a configuration and activate this. And as you see, again, the options are reduced. As for secondary members, also you don't need the capacity design and the ductility rules. Okay, but I now want the primary seismic elements. As an example, I have here a configuration for secondary seismic elements, as it could be useful in another building. But now for me, I go on here. Then you have the option to change the design situation to accidental design situation for the definition of the partial factors for materials. And then we can come, I collapse all again, we can come, now here we were, to the behavior factors. This is a check. If you activate this, you activate that you want your behavior factor to be checked. So the used behavior factor is checked whether it's below the upper limit for the factor. And you have the option to define user-defined manually the behavior factor that was used for receiving the loads you assign in your model. or you have the option to, if you did the dynamic analysis in our program and you used the response spectrum, you have the option to take this value over from there. So I do it. We saw our response spectrum and we saw that we have the behavior factor, which is 2 for this situation or this model, and I want it to be taken in my check. Yeah, and then you have here settings that you can do for the basic value of behavior factor that goes into the upper limit value. If you have this special quality system plan, for example, according to this clause of the standard or something, this has to be looked at with time. Yeah, the value of behavior factor, the basic value, can be found automatically dependent on the system type and the ductility class you assigned, or you also can define it. You can set it directly here, select it by yourself, or you can also give a user-defined basic value. Yeah, we can have a look at this check shortly. As I said, I already have results in my model. If you look here at the concrete design, we see, and I can do it here too. We see here all the design checks that are done, and the check about the behavior factor is our check 0404. And we can have a look at this. If you double click on the design check type, no, I want to go back to concrete design. If you double click on the design check, you get into the design check details, and we shortly have a look at it for the behavior factor. And here you can very well follow what the program does. So we have our basic behavior factor and the factors that you defined in advance, and the limit value is found. And then it is compared with the used behavior factor for the calculation of the loads, and we see that it's taken from the response spectrum, and we have the 2 here. So this works well, that we take over from the dynamic loads these parameters that we need for the design as well. Okay, I can also reach the configurations from the table here. We have the input data here, and here also, as you can see, our configurations and the seismic configurations here. So I can also open them from here. And we are back in the configurations. I can collapse them, and now we come to the capacity design rule. With the capacity design rule, you can control the failure mechanism of the model of the structure, and for these 2 main checks are required. And for this, I will go to the presentation shortly. What we need is to fulfill this equation 429 of Eurocode 8, which is about the relation or the ratio between the sums of the design values of the moment resistances of beams, which is here with B, and columns. And this is this rule, according to this equation, is the strong column weak beam concept. So we require that the moment resistances of the columns are stronger than the moment resistances of the beams at a joint. So we have to check for all joints, for all nodes, this equation. This is the one check, and the second check is the related shear capacity design check, capacity design shear check. This is in that situation when you reach the moments that equal the moment resistances, then you can calculate the related, let's say, shear force in the member. And for beams, you also have to assign the quasi-permanent load. And this shear situation you have to check, because you don't want a failure earlier because of shear, which is also brittle. So you have to check this situation when you have the moment resistances reached at the member ends and the quasi-permanent load. This shear force has to be checked as well. So let's go to the configurations again. In the first checkbox, we activate that strong column weak beam rule. We also can see here the equation 429. And in the second check, we activate the shear force. Shear check for capacity. Then you also have the option to define overstrength factors for beams and columns. And we have here the detailing rules and the ductility checks. We have here at the top the curvature ductility checks, which are provided indirectly via the requirements for detailing rules. So with fulfilling these detailing rules, the curvature ductility check can be done. And we have one checkbox for the beams and one for the columns. And for these checks, also the limit value for the curvature ductility factor is needed. And here again, you have the option to take the values Tc and T1 from the dynamic load, from the response spectrum that you assigned. Again, you can assign it here. If you don't want this, you can assign these values manually, or even assign a curvature ductility factor, a limit value for it manually. Okay, but we have this situation. I have the periods taken over from there. Okay, and then we have here some further detailing rules that are required from you code 8 for the beams and for the columns. And yeah, you can give a user-defined length of critical region. And here we have the geometrical constraints provided and the material qualities. And in this box, you can activate if you want to also calculate the required reinforcement that results from the seismic design situation. Okay, yeah, this is it for the seismic configurations as an introduction. Now we will have a look at some checks. As you saw, we provide the option that you can select quite detailed which checks shall be done or shall not be done, and this allows you to make specific configurations for your situation. For example, I have for the top floor another configuration which doesn't do the strong column weak beam check, as I don't need it for the upper for this floor. And you can also have a setting for the secondary members, and you can modify it quite functionally for your situation. Okay, and now we have a look at results. I will at first activate this check. It's the EQ 400, and this is the capacity rule, the strong column weak beam check. If we go here to wireframe model, or maybe the transparent model. No, let's go to wireframe. You can see that in all these nodes where columns and beams come together, this check is done. And I want to now have a look at this with you in detail. Therefore, I use these members that I have given names here, as it is more easy to work with not all of them in the same time. I have prepared guide objects here. I have an object selection which contains these members, and I can click on here and then set my visibility so that only these are displayed. And if I go on this view, I see my selected members, and I have a kind of shadow display for the rest, and I can also switch this off. Sometimes it's good as an orientation, but now I don't want to see this. I want to have a look at these members. Okay, we have the results graphically, and we have them also here in the table. I can go on design ratios on members, and here I have now, if I select them also, no, I also have here, I have my EQ 400, the strong column weak beam rule. And we come to the design check details. Okay, yeah, here you can see that the program does the check. The strong column weak beam rules, we do check in the column members. So if I can open numbers for them. I have here my column number 22, and in this member 2 at the end and at the beginning, the strong column weak beam rule is checked. So if we look here, now I'm at member location 3. I want to also see the local axis. So position 3 in this member is this node here, and I want to have a look at this. So I again go to location 3. And as we can see, we have the Y direction. So all these indices, they are dependent on the column. So I have the moment resistances around Y-axis, around the local Y-axis of the column that are checked now at first. And for this, around this node, around the Y-axis, so in this direction, the beam 67 is relevant. So the program found this, found beam 67 and took its moment resistance. And then the columns from top side and bottom side of that node, they are considered here as well. And we can see, if we click the values off and just look at the formulas, we can see that we do the check, of course, in both rotation directions. Let's say we have here the minus around Y and the positive around Y, and the same for the Z direction. And for the Z direction, the other member, the member 66, is considered. Now here we don't see it, it's now in the direction of view. Okay, so let's go back to values. I want to now with you find the value for the moment resistance of the column. Therefore, we can, here in the column, we are in this member number 22, we are in this column, we can open this result diagram and we can check the normal force in this column. And we have a result combination, so we have to check a range of normal forces that can appear. Our normal force lies between minus 26, let's say, and minus 348. And with this information, we can go to our interaction diagram that you can activate here. And then you have this register open here. And if we look at this, we see that with a higher, let's say, negative value of normal force, we have a higher moment in the column. And for our check now, the worst case is the lower value of moment resistance in the column. So that's why I have to consider the minus 26 normal force, as it's the worst case and the safe side. And then I can look in this diagram and take my M around Y for the situation that MZ is 0, and we see we have 121.3, and in minus direction the same as I have longitudinal reinforcement on both sides the same. If I would have different reinforcements here, I would have different moments. So I can come back and we see, yes, our program found the right values for member 22 around Y for the resistance, and here in the other direction. Yeah, and you can do this if you need. You can follow where these values come from. Okay, that's it for the check of the strong column weak beam, or the EQ400. Then we have, as we spoke about, here you can see that the 66 is for Z direction relevant. Then we can check the shear force from the shear check for capacity design. It's for columns in our program. It's the 0406 design check, but you can also read it here in the description. Here I have to look at, I have some values that are higher than 1. We will have a look at this now. So I will open this member 23 and we can have a look at check 406. Yeah, here it comes. And yes, as shortly shown on the slide, here now the moment resistances from member start and member ends are taken, divided by the length of the column, and in this way the shear force in this location is calculated. And this again for the different rotation directions, let's say moment directions, orientations. Yeah, and then we have a shear force, and then with the reinforcement, the shear reinforcement, the normal shear check is then done. It's compared with the shear resistance. Yeah. This is it for the column. Maybe we can have a look. We have more checks I will show later, but we can look at the curvature ductility check for this column. It's hidden in this check. It's the 417. I double-clicked on it shortly. You can find it there. Yeah, here it's a check about the reinforcement, the mechanical volumetric ratio in columns. It's for giving the for making sure the curvature ductility in the column in the critical region. And this is the check where also the values from the response spectrum are needed and considered. Yeah, but you can follow this in detail in the program. Okay, then we can also have a look at the beam checks. As I said, the moments of this node are checked in the column, so we have checked this. Then we can also check the beam. Yeah, we can go into this one. Here also some. Yeah, and what I want to show is that we here have again this from the moment resistances, this shear force, and we have added the quasi-permanent load. And again, like this, the shear force is calculated and then it's compared with the shear resistance provided by the reinforcement. Yeah, this for the beam, and for the beam we have also the for curvature ductility provision, let's say. We have the requirements according the maximum reinforcement area in beams. I double-clicked on it shortly. There it is required that the on the compression side, you at least have placed 50% of the reinforcement of the tension side. Yeah, and you can follow the information here later in detail. So this is it for the beam, I think, and we also have here these about the distances of stirrups. Yeah, that's it in detail. I want to again show the whole structure. Therefore, at first we deactivate the local access systems and the numbering, as it is too much when we see the full building, and we can go back, cancel the visibility mode and see the whole structure, and also uncheck this. And then we can check this for the whole system. And if you want to modify the way of the display of the results, you can also change the ratios here. So here we have the strong column weak beam rule checked for the nodes. Then we have here the material checked for all members, and we have the geometric rules checked. And yeah, I checked the behavior factor just for one, but it's for all the building valid. Only I did the calculation just once. These are the shear results we looked at, and here we have a check according the normal force in the columns and compared with the limit value. And yeah, this is the curvature ductility check for beams, and this is the minimum reinforcement check for beams. And yeah, the distances of the stirrups we saw. This is the number of longitudinal bars that are required according to Eurocode 8 in columns. And then we have some more column checks like minimum reinforcement, maximum reinforcement, and also the spacing of stirrups. Yeah, okay. This is what I wanted to show regarding the seismic design for concrete members as an introduction. This shall be it for this webinar. As I said, as a very short prospect, I would like to tell that we are, regarding the seismic design, we are currently working on the required reinforcement. We have several of these checks already considered in the calculation of the required reinforcement. We are currently working on consideration of the capacity design checks and the required reinforcement. This will be one of the features that will be the next that we will provide to you, and we also work on the performance improvement for the performance of our seismic design. And the next step, the next project will be the deep beams and shear walls, the design for it. This, yeah, as a short prospect for the seismic design. Okay, then that's it from my side. Andreas, I would like to give the word back to you.
Okay, thank you, Juliane, for this nice presentation. I would like to show you where you can find the recording of today's webinar, the model, and the PowerPoint slides. I take over the screen to mine. Just a moment. Well, before I show the website, I would like to give you a hint. If you want to book your free online appointment, such as a product demonstration, just contact our sales team. You can click on that link or scan that QR code. Also, if you want to get the non-binding offer for any product of the Dlubal software company or any add-on, just contact our colleagues. So then I show our website, dlubal.com, and under news and events, you can find the webinars. That's today's webinar. Now, I would like to invite you for the next webinars next week about the new add-on, time history analysis. Then the most frequently asked questions webinar, and the week after next week, a webinar about R-Wind, and then how to integrate artificial intelligence to RFEM using the API. So, okay, I click on today's webinar. You will get the link or email with a link to that page. Yeah, and then you will find the recording in the middle here. You can already download the presentation slides and also the model. But yeah, just wait for the email and then the recording will be online. Okay, that's also all from my side. I thank you for your attention. Thanks to Juliane for this nice presentation. Thanks to Alexander for the help by answering your questions. Yeah, maybe a last hint when you leave the webinar, there's a small survey. You can score the webinar or you can enter wish for future webinars. Yeah, just note that the worst score is 1 and the best score is 5. It would be nice if we meet each other in a future webinar. If you are registered for our newsletter, you will get an invitation for the future webinars. Okay. Yeah, I wish all a nice rest of the day and bye-bye.